नमस्कार दोस्तों, हाउ आर यू। मैं आज आपको रिवीजन पैक करा रही हूँ। EMFT के क्वेश्चंस हैं। फर्स्ट क्वेश्चन है द इक्वेशन EF इज इक्वल टू माइनस डी फाई, इसको बोलेंगे माइनस डी फाई बाई डी टी, वेयर EF इज द EMF and phi is the flux linkage in a single turn coil, can best represent Faraday's law and Lenz law and Biot-Savart law और Biot-Savart law। तो इसका जो राइट आंसर होगा क्या होना चाहिए बताओ। ये जो इक्वेशन है आपकी EF इज इक्वल टू माइनस डी फाई बाई डी टी, what does this phi denote? It denotes the flux. So this equation represents the Faraday's laws of electromagnetic induction. It states that magnitude of induced EMF, ये क्या है? Induced EMF. Magnitude of induced EMF in the coil is equal to the rate of change of flux phi that linkages with the coil. Negative sign represents Lenz law. इसका मतलब होता है ये Lenz law represent करता है, which states that the flux produced opposes the whatever the flux is producing in the given coil. The flux produced opposes the rate of change of flux. So Lenz law states the direction of current induced in a conductor. If this is a conductor, so direction of current induced in a conductor by a changing magnetic field is such that it always opposes the change in magnetic field which produced in it. So Lenz law is based on the law of conservation of energy. So your right answer will be Faraday's laws and Lenz law. Lenz law क्या state करता है? Direction of current induced in any given conductor whenever there is a changing magnetic field, and that changing magnetic field happens to be like such way that it always opposes the change in magnetic field which produced it. It always opposes that change in magnetic field which opposed it. So right answer will be second. Next question is, if a circular conductor carries a current of I ampere having radius r meter, this is a circular conductor, it carries a current of I ampere having radius r meter, then the magnetizing force at the center of the coil is given by whatever. Out of the given options, what should be the answer? You should be knowing that it should be this I by 2r ampere turns per meter. For example, if this is a circular conductor and here it is the radius a, for example, this is the given magnetic field intensity, okay, its coordinates are 0 0 h, okay. So electric field intensity at the coordinates 0 0 h, okay, due to current I flow in a circular loop, this is the current flowing in that circular loop, due to current I flowing in a circular loop coincides with the z-axis. This is the z-axis. जो भी current flow कर रही है, it is coinciding with this z-axis. So it is given by magnetic field intensity H is equal to coordinates are 0 0 h I a square upon 2 of h square plus a square to the power 3 by 2 a by z. Okay, sorry, az is the unit vector, okay. So for the given question, if a is equal to r and h is equal to 0, then it should be equal to I of r square by twice of 0 plus r square to the power 3 by 2. The answer will be I by 2r. Okay, that means it will be cancel out, and this r square r cubed I by 2r. So the right answer will be I by 2r ampere turns per meter. Next question is, the ratio of amplitudes of electric field and magnetic field strengths has the same dimensions. Is that of permittivity, inductance, capacitance or impedance? It will be impedance. It is the ratio of intrinsic impedance. This you all know. Intrinsic impedance of the wave is defined as the ratio of electric field and magnetic field phasor. That is, it should be j omega mu upon sigma. For free space, the intrinsic impedance is a real quantity. So this eta is equal to eta naught is equal to 120 pi, and this eta is equal to 377 ohms. Okay, so this you should be knowing. Okay, next question is, two parallel conductors are carrying currents in the same direction. Okay, supposing these are the two parallel conductors, they are carrying currents in the same direction. Okay, which of the following statements is correct? There is a rappelling force. No. The force, first option is wrong. The force increases when the current is decreased. No. There is an attracting force between the conductors. Yes. The force increases when the distance between conductors is increased. False. So if two wires carrying current in the same direction, they attract each other. You know, like charges attract each other, unlike charges like charges repel each other, unlike charges attract each other. But here it is talking about the current direction which are flowing in the same way, and it is happening in the case of two parallel conductors. So here the force that will happen, it will be F1, this will be also F1. So both forces will try to uh, attract each other. If the two wires carrying current in the same direction, they attract each other, otherwise they will repel. So the answer will be C option, right? Next question is, when a dielectric is placed in an electric field, the field strength increases, decreases, or remain unchanged. See, a dielectric is what? It is an electric insulator. It is an electrical insulator, okay, that can be polarized, by an applied electric field. Okay, when a dielectric is placed in an electric field, whenever a dielectric is placed in an electric field, so what happens? Electric charges do not flow through the material. Electric charges do not flow to the material as they do in electrical conductor, hence the electric field strength decreases. The right option will be D, because here dielectric is acting as an insulator, does not conduct any electricity. It gets polarized by an applied electric field. When this dielectric is placed under the application of certain electric field magnitude, then the charges are not going to flow. That's why the electric field strength decreases. Next question is, the unit for polarization is simple, it's Coulomb per meter square. You know, polarization means the process or phenomena in which the light waves or other electromagnetic radiations are restricted to a certain direction of vibration, usually specified in terms of electric field vector. The electric polarization vector is equal to the, this is what happens if this is P, it is electric polarization vector. This electric polarization vector is equal to the average number of electric dipole moments per unit volume. So its unit will be Coulomb per meter square. It means the light waves or the electromagnetic radiations, they are restricted to a certain direction of vibration in terms of electric field vector. So this is polarization. So this is Coulomb per meter square. Next question is, what is the value of tangential component of electric field in a dielectric conductor boundary? If this is a dielectric and this is a conductor boundary, okay, so what is the value of tangential component? The value of tangential component of electric field in any dielectric conductor boundary is 0. That means E1t is equal to E2t is equal to 0. A conductor, there is a conductor, it is placed in a static field. Static means it is constant. It will exhibit or induce some charge on its surface, okay, so as to have zero field inside. For an ideal conductor, electric and magnetic field inside it is 0. For an ideal conductor, what happens? That electric and magnetic field inside that ideal conductor is always 0. The given situation is like, this is a dielectric conductor interface. So here E2t and E1t is, here E2t is 0 and here E2 and normal components are also 0. So a conductor dielectric interface satisfies the, see, it satisfies the following boundary conditions, like H1t minus H2t, this is equal to Js. Then B1t is equal to normal component, B1n is equal to B2n. Then here E1t is equal to E2t is equal to 0. Then here D1n minus D2n is equal to rho s. So for a conductor, these are the 4 boundary conditions. For any conductor, you have tangential component H2t equal to E2t equal to B2n is equal to D2n is equal to 0. So here what happens? H1t is equal to Js, okay, and here what is actually happening? It is making this, when it is 0, किसी भी कंडक्टर के लिए this H2t is equal to E2t, ये 0 होगा, B2n ये भी 0 होगा, तो H1t becomes equal to Js, B1n is equal to आपका क्या होगा, B1n is equal to B2n, ये 0 ही होगा, this will be 0 only. E1t equal to E2t 0 and D1n क्योंकि ये 0 है तो D1n is equal to rho s, ठीक है. तो ये आपको बाउंड्री कंडीशंस हैं. नेक्स्ट क्वेश्चन है द मैथमेटिकल एक्सप्रेशन फॉर हाफ पावर बीम विड्थ इज. दिस इज वेरी इंपॉर्टेंट. बीम विड्थ क्या होता है एक्चुअली? बीम विड्थ इज द अपर्चर एंगल फ्रॉम वेयर मैक्सिमम ऑफ द पावर इज रेडिएटेड. द टू इंपॉर्टेंट टर्म्स आर HP, BW हाफ पावर बीम विड्थ एंड फर्स्ट नल बीम विड्थ. ये इंपॉर्टेंट टर्म्स होते हैं. जो एंगुलर सेपरेशन होता है इन विच द मैग्नीट्यूड ऑफ रेडिएशन पैटर्न, एंगुलर सेपरेशन in which magnitude of radiation pattern, this is what radiation pattern, magnitude of radiation pattern reduces by 50% or minus 3 dB from the peak of the main beam, from peak of main beam. RP is what? Radiation pattern. It is radiation pattern. So angular separation in which radiation pattern reduces by 50% or minus 3 dB for peak of main beam, it is half power beam width. Okay, and half beam width is the area. What is this beam width? The actual width of the beam. Beam width is the area, okay, where maximum of power is emitted, where maximum of power is emitted. Okay, so which is the peak power? इसको हम क्या बोलेंगे? peak power बोलेंगे. Now half power beam width is the angle in which comparative power is more than the 50% of peak power is the operational radiation field of the antenna. तो इसका जो एक्सप्रेशन होता है वो होता है 70 लैम्डा बाई डी. हाफ पावर बीम विड्थ इज 70 लैम्डा बाई डी. ठीक है, तो यहाँ पे अगर आप इसका ग्राफ भी रेडिएशन पैटर्न जैसे ये है, ये एक बीम हो गई, यहाँ पे ये इस तरह से हो गया. ओके, यहाँ पे अगर आप देखो तो ये हो गया आपका HP BW, यहाँ पे ये हो गया 0.5, यहाँ पे 0.5 एंड दिस इज ये जो है इसको हम क्या बोलेंगे? ये हाफ पावर, ये हाफ पावर दैट मीन्स हाफ पावर पॉइंट लेफ्ट है और ये हाफ पावर पॉइंट क्या है? राइट है. ओके, तो इसको हम क्या बोलते हैं? मेन लोब. इसको मेन लोब बोलते हैं. ठीक है, तो द फिगर बिलो शोज हाफ पावर पॉइंट्स ऑन द मेजर लोब. दिस इज द मेजर लोब. ओके, नेक्स्ट क्वेश्चन है इफ इलेक्ट्रिक फील्ड E is E naught I and magnetic field is B naught J, what is the direction of pointing vector? देखिए पॉइंटिंग वेक्टर क्या होता है? इट इज द क्रॉस प्रोडक्ट ऑफ इलेक्ट्रिक फील्ड वेक्टर एंड मैग्नेटिक फील्ड वेक्टर. सो दिस विल बी 1 by mu naught of E cross B. S is what? This is pointing vector, right? So E is electric field, B is magnetic field. So S is equal to, you can write it as E cross H. So H is B is equal to mu H. This you all know. So unit of pointing vector is watt per meter square. So you know the pointing vectors determine the flow of energy in a region or outside the region. तो cross product rules क्या है? I cross J is equal to K, J cross K is equal to I, K cross I is equal to J. Now इसका रिवर्स करो. J cross I is minus K, K cross J is equal to minus I and I cross K is equal to minus J. तो यहाँ पे गिवन इलेक्ट्रिक फील्ड आपको जो दिया है E naught I and B naught J, जब आप इसको मल्टीप्लाई करते हैं you will get E naught I into B naught J. These are the unit vectors, right? So this will be E naught B naught, okay, and this is I cross J, right? So this will be E naught B naught and this will be K. So the direction is along with K. तो आपका ऑप्शन क्या आएगा? I cross J K. तो इसका ऑप्शन होगा 2 option is the right answer. Simple answer है. Next question है last. When the load impedance is equal to the characteristic impedance of the transmission line, then the reflection coefficient is standing wave ratio is, it's very easy. आपको पता है जो VSWR होता है, it is a measure of mismatch between the load and line. So it is equal to Vmax by Vmin and this is equal to Imax upon Imin and this VSWR is denoted by S. So this S is equal to 1 plus rho by 1 minus rho. So this reflection coefficient is what? This is equal to ZL minus Z0 by ZL plus Z0. So for reflection coefficient, this is the load reflection coefficient and it is varying from 0 to 1. So VSWR will vary from 1 to infinity. इसकी वेरिएशन है ये. अब इसमें देखो आप इसमें वैल्यू रखो ZL माइनस जेड नॉट है, तो ZL इज इक्वल टू जेड नॉट है, मैं इसको ऐसे ही भी लिख सकती हूँ कि ट्वाइस ZL हो गया, तो ये तो ज़ीरो ही हो गया, तो रिफ्लेक्शन कोफिशिएंट एक तो आपका ज़ीरो आ रहा है। दूसरा, ये और ये इन दोनों में से ऑप्शंस होंगे। इसने क्या पूछा है, रिफ्लेक्शन कोफिशिएंट, तो पहला रिफ्लेक्शन कोफिशिएंट, तो फर्स्ट फोर्थ ऑप्शन इज जीरो। नाउ VSWR मुझे निकालना है, तो S इज इक्वल टू 1 प्लस जीरो बाय 1 माइनस जीरो, सो दिस विल बी 1, सो विच इज द मैक्सिमम वैल्यू बिकॉज इट वेरीज फ्रॉम 1 टू इन्फिनिटी। तो इसका राइट आंसर क्या है, इसका राइट आंसर होगा, व्हाट विल बी इट्स राइट आंसर, इसका राइट आंसर होगा 4, कैसे हो गया, रिफ्लेक्शन कोफिशिएंट, हाँ सॉरी, ये और ये होगा, रिफ्लेक्शन कोफिशिएंट इसका एक तो जीरो होगा और SWR 1 होगा, ठीक है। तो ये आपका था। थैंक यू वेरी मच। अगर आपको पढ़ाने का ढंग अच्छा लगा हो, इसे प्लीज़ शेयर एज मच एज यू कैन, प्लीज़ लाइक शेयर एंड सब्सक्राइब। थैंक यू वेरी मच।